square root of any real number on number line. How do we find that out geometrically? We have been learning about this earlier, and we have seen that if we follow these 4 simple steps and if we make this simple geometrical construction, then the length BD represents square root x where x is any real number. So using these 4 steps and drawing this simple geometrical construction, we can find out the value, the measure of any square root of any real number. And earlier we have also seen how can we get this measure, that is the square root x measure or this length, onto the number line. So in this video we are really going to focus on why this works. That is, why if we follow those 4 steps we can always find out square root of x. Why is this always it works? So let's do one thing. Let's get our geometrical construction like the way we have done it over here, right? And now what we are going to do is as follows. We are going to first join the point O and the point D. So we will get something like this, right? After this, what we are going to do, we are going to write all of these lengths, like what is O, what is AO, what is AB, and what is AC. So let's do this now. So these are the different lengths, right? So what is AB? Remember, AB is the length that we started with, right? So AB is x. Next, let's find out what is BC. Well, BC is 1 unit. We started with AB, then we extended AB to point C such that BC is 1. So AB is x and BC is 1. Now, what will be AO? Remember, O is the midpoint of AC, right? So AC is this length. So we can say that what is AC? Let's do it over here. So AC is simply AB plus BC, right? It is AB plus BC. Now, or in other words, AB is x and BC is 1. So AC really is x plus 1. Now, AO or OA is the midpoint of AC, so it should be AC by 2. Yes? And AC is this, so OA will be x plus 1 by 2. So we have found out what is AO. Now we know what is AB and we know what is AC. So now what is this length? What is OB? So we can think of OB. Let's take a look. Let's write it over here. So what is OB? OB, we can think of it as AB minus AO, right? So we can say OB is equal to, let's write this. So AB, right? So this is AB minus OA. Now, what is AB? AB is x. And what is OA? So OA is this number. So it will be x plus 1 by 2. So then this will be, if we take 2 as the LCM, so this will be 2x, then minus x minus 1, or this will be 2x minus x is x, x minus 1 by 2. So now we know OB. OB is x minus 1 by 2. Next, what we are going to do, we are going to now look into the triangle OBD. Remember, we are trying to find out the length BD. We are trying to find out why this length is always square root x. That's what we are trying to find out. Now, if you look at triangle, BD, sorry, OBD. this is 90 degrees by construction. So in our triangle OBD, it's a right triangle, right? Because angle B is equal to 90 degrees. So applying Pythagoras theorem, we can say OD square equals OB square plus BD square. Why is that? Well, we know Pythagoras theorem states in a right triangle, hypotenuse, which is a side opposite to the 90-degree angle, OD square equals the sum of squares of the other two sides. So OD square equals OB square plus BD square. Or we can say then BD square, which is what we are trying to find out, will be equal to OD square minus OB square. Right? So simply we are going to move the OB square on the other side. Now let's see what we know. So we have here BD square equals OD. So do we know the value of OD? Actually, yes. Why? Because we know that OD is equal to OA. Why is that? Because O is the midpoint, and taking radius OA, we drew this semicircle, which was the last step, right? Or step number 3. So OA and OD are radiuses, right, of the same circle or same semicircle. So we can replace OD with OA. OA square minus OB square, right? So now let's put the values. So what is OA? OA is this number, which is x plus 1 by 2. So it will be this square minus what is OB? OB is this, x minus 1 by 2. X minus 1 by 2 square. So what we have here, we have something square minus something square. So you can think of this as, let's write it here, something like a square minus b square. So if you have a square minus b square, we know there is a formula which is a plus b times a minus b, right? So we can say BD square, we are trying to find out what is BD square. Let's give ourselves a little bit more space. BD square equals, now it will be a plus b, right? A plus b. So this whole term is a. So let's write it as x plus 1 by 2 plus, this is the plus, and this is the b, which is x minus 1 by 2. So multiply by a minus b. So a is this term again, x plus 1 by 2 minus, this was plus, a plus b, this is minus, b is this term. Now let's continue to solve this. So this one will be, so 2, we can take 2 as the denominator. We will have x plus 1 plus x minus 1, right? In the numerator, that's what we will have. Multiply by, over here we are going to have 2 as denominator, and we will have x plus 1 over here minus, this will be x, and minus will be plus 1. So this is what we have. Now let's look at this. So plus 1 minus 1 will cancel. So here we have 2x by 2. So we have 2x by 2 over here, right? So this term is 2x by 2. Multiply by, what do we have here? So plus x minus x cancels out. We have 1 plus 1, simply 2 over 2. Or we have this as 2 and 2 will cancel out, simply x. Multiply by, this is 1. Or x. So BD square. So BD square equals x. So we can say, from here we can say that BD, the length BD, is square root of x. We can take square rooting both sides. If BD square is x, then we can say BD is square root x. So this is how we have proved that if we do these 4 steps, then the length that we get BD will always represent square root of x.